Okay. So right now I'm here is looking at the Node.js course from Zero to Mastery Academy, and because here we are on the GraphQL section, and I'm going to make a huge overview of what I have learned so far in this section. So GraphQL is a new way of building front-end and backend. It's a query language where the beauty of this is to see how all of these different pieces of data relate each other in your server. And it all starts by describing the data using schema, and with GraphQL query allows you to fetch the data that you want. So it's much like selecting property in an object where the the idea behind that, of the reason, or one of the reasons behind using GraphQL, is that since the GraphQL query really match closely the resulting objects, we can predict what our query will return. And that includes the input fields or the property, regardless how the data is stored, whether it is a relational database, graph, white column, key value, or a document base. So the reason, one of the fundamentals of looking at the GraphQL query is because it simplifies things by just having one single entry point, in contrast with REST, where if you want to get some data, and especially if you want to combine several collections of data, you need to query, or you need to make an individual request to that endpoint and to get that response. And then build it up or compose your result in the front end and filter out the relevant data. So this is the two issues that GraphQL is solving, the underfetching and overfetching. So underfetching means that anytime we make a request to the server, we lose time, especially querying multiple collections, and that is load time that is increased when we do this first initial load, when we are loading our application. So first time, this issue is because you have to query, and again, just to paraphrase this, anytime you query multiple collections, or you hit multiple API endpoints, it adds load time page. And the other is the overfetching. Since the server is sending additionally unnecessary data, so you need to filter out the data in the browser to show only relevant data. And before diving into these two issues, I look at our first GraphQL query, looking front-end browser-based tools like GraphQL, what allows you to build GraphQL queries and have a first-hand approach on how to use that. And well, highlight some of the things, especially like by default, all GraphQL queries fetch data. And then I also look at GraphQL query in action, which is that it generates the schema based on the type system that we build, or the capability that this GraphQL server expose. And here's exactly what's presenting is the issue that we were talking, or that I was talking, the underfetching and the overfetching, and how GraphQL solves this by having one single entry point. So there is no need, or there is no more underfetching, and also solving the overfetching by getting the data that you want in the response. So there is a trade-off of using GraphQL. So the first advantage is that no more overfetching, underfetching. You have schema and types by default, and speed up the development. The trade-off is that, well, this flexibility adds complexity, especially for those developers that need to know what are or how to build this new way of APIs and how to interact with them. It is difficult to catch, especially because with REST we already have proven methods that allows to do that, and it's not RESTful ultimately here. So similar to the flexibility that add complexity, most developers are familiar with the RESTful or this architectural design. So this is again a new process to build API backends. So GraphQL works really nicely with RESTful API, and there's some scenarios in where it's good practice, especially for authorization, to combine them. So GraphQL works it's similar as an HTTP entry point. The idea here is that the way to query that data is through a HTTP post request, where you send additionally relevant data for that. So then I look at exploring the GraphQL implementation, which is something that was created by Facebook in 2012, and then the front end tool for building this GraphQL uh, and how React framework or how React apps can interact with GraphQL server in a much more friendly way. And then the GraphQL API, which is allow you to build front-end and back-end GraphQL applications. So I started to solve how can I use GraphQL in Node using an Express application, especially a Express middleware for that. And here is where you by default, once you include is the middleware and you inject that, and by passing is the GraphQL HTTP server, you are creating is the GraphQL server. Uh, and it all starts with the type definition system, where you describe the capability of this GraphQL server and uh, which is used to check if a request operation is validated, and again, all of these things that I mentioned here is this specification. This comes here on the type system. When you look here at the type system, okay, which is this, the GraphQL type systems describe the capability of the GraphQL servers, and it is used to determine if a request operation is valid, something that I mentioned, to guarantee the type of the response result, and describe the input value types of variables to determine if the value provided at request times are valid. So this is very interesting because once I create this, all right, and I can look and I can show you using the Visual Studio Code here, where here I create this. Okay. Well, it's actually loading whatever is on the WSL, and here we are. So yeah, this is our server. Okay, here our server is quite different from what is here, because here we just want is to creating our first GraphQL query and test that using tools like Postman. Okay, tools like Postman or Insomnia REST. I don't think exactly Insomnia.rest, which allows you to test API. or debug, document, and so on, right? Similar to this. Uh, so okay, cool. Now, uh, so after I saw that here, so after I saw how can we create our query, and so by using the build schema, which is a method provided by the GraphQL, we define as a type system as a string here. So setting the type of the data to that our API support. Query is the entry point for all of the GraphQL server, and you need to define is the type system and the initial value where they have, or the root value where that they're gonna have, right? So this is a screenshot of using Postman to test our endpoint here. Oh, and then I look here at a summary of designing an e-commerce scheme, which is this, right? Where we define, for example, the product, the review, the ordering of the ordering items, and how by defining the type, we can reuse in an array collections as well. And again, following is the input, in, yeah, following is the types, okay, where that allows you to use that. So for example, in object, so it's all about this definition. Input and output types and scalars. And right now I am looking at this. Here is describing is what are the exactly what are the here describing what are the types that you can use. For example, int, float, string, boolean, id, which is specifically or allow you to represent unique identifiers. Okay, scalar extension, objects, interfaces, union, enum, input objects. So yeah, this is by looking at the types. Okay, in here also is defining is a very simple common e-commerce application, and again as their default value. So if we want to activate the graphical or this front-end tool browser based test uh, tooling for our GraphQL server, well, we just only have to set that flag to true. And if we run this, again, start, right? It says this, no, no was not found. Okay. We're using here is the Node Manager version. Which version of Node are we using here? It says no, we're not using anything. Okay, I would like to close this and open it again. It's saying it didn't load that. Perhaps open is a new batch here. It's saying it's not loading our default configuration that we have on, yeah, it's not loading our visual configuration where we have here on the WSL. Doesn't matter. However, I just want the print working directory here to access directly to this. And so if I enter npm start, it say the same. For some reason, it's not able to load this. nba help. Interesting. But there is npm list. Okay. Uh, so is yeah, okay. The issue is that it's not set as default. So what we can do is use version 14, and we're using it the version 14 due to compatibility issue here. Okay, and when I hit npm star, so our GraphQL server is running on the port 3000. So look out at the port 3000, and of course, because we didn't define anything in the root directory, once we access to the GraphQL path, we are able to see exactly our graphical. Great, cool. So with this, okay, we can even stop this. Mm-hmm. And let me see if no, it's actually no. We have to tell from this terminal. I want to close a couple terminals here. Okay. Hey, no version manager. I would like you to use the 14 point whatever version you have, but you don't use the autocomplete. No, 14. That's right. And perfect. npm start. So hit it one. Cool. Okay. Um. So as I move on here, okay, especially on the course, okay. So once I design this e-commerce schema, so deep nested objects is very common in any e-commerce application or any application, which is something that is not here, okay, or any application with some technical depth, with some degree of technical depth. So which makes them perfect candidate for GraphQL. It is actually amazing how easy it is to query really complex data structure. Okay? Uh, exactly. It is amazing how really easy it is to set up really complex data structure for exactly the data that we need. So our API is organized in types and fields rather than endpoints. So making multiple API endpoint or making multiple endpoints or querying multiple endpoints for combining data on the clients to filter out and show the user relevant data is unnecessary, like in a RESTful API. So between these 2 days and these last 3 days, I started to show is the GraphQL tools. So as our project gets larger, so instead of keeping everything on one field, which imagine that you have to define many types or the capability of your GraphQL server increase. So as our project gets larger, instead of keeping one in every one file, so there's a couple of questions that I wrote here. So in terms of scalability, it's like how do we break down our schema into multiple files? For example, this. How do we break multiple schema, or how can we break multiple schema in separate different files? Structure of projects based on functionality. The following is the MVC pattern or the MVVC or the MVV whatever. Organize our server when we need to add more complex logic to fetch our data. And this is very, very useful. So GraphQL tools greatly help us here, which is this. So I hope we can open up this URL. Yes, it did. So it's a set of utility for faster development of GraphQL schemas. So it's an open source set of utility that simplify how we make GraphQL server. And it is used under the hood by Apollo GraphQL framework. By them. So the GraphQL tools is being used, or underneath the hood, Apollo used this tool. So the great thing of this is that GraphQL is a standalone package, and since Apollo is a service company of GraphQL, it's not a good idea to fully commit to their service unless you have very reasonable approach or let's say some agreement with them that allows you to do this, or where you can work with them together. So that's where we are. Okay, and as we move on here, the graphical tool here, modularize large GraphQL project schema is this. Is this. Okay.
Let's keep it going in the next video. I'll see you.
Okay, I
Well,
already
project.
saw that.
We're going to structure it like a large-scale project by feature.
Okay, so what I'm going to do here is part of my pattern is to write down here modularizing large project schema and put it here, and then let's leave this open. Oh, that was what I did. Exactly. Is I'm gonna close this. Is to start listening here.
Welcome back. In this video,
And take notes.
we're going to modularize our GraphQL project. We're going to structure it like a large-scale project.
Okay, so here we are going to structure it like in a large scale project.
To modularize our GraphQL project, we're going to structure it like a large-scale project by feature.
By features.
So that not all of our schemas, types, and server logic live in a single file. So far, we've been using this build schema function that comes from our GraphQL.js library, that reference implementation from Facebook. This takes a string with our schema defined using GraphQL's type system, which is fine for smaller projects, but if we wanted to split up this schema of ours into separate files, it helps to use GraphQL tools. Specifically, this executable schemas feature. Instead of
okay, so if we want to execute
system, which is fine for smaller projects, but if we wanted to split up this schema of ours into separate files, it helps to use GraphQL tools. Specifically, this executable schemas feature. Instead of talking about it, let's see it in action. The way that GraphQL tools works is that we can import the different tools that it provides as needed by our project.
So the way we can use is GraphQL tools. And the way it works. Okay, the way it works
Is that we can import the different tools that it provides as needed.
So it works is that we can import different tools as we need it. Is modularized
by our project. Each tool lives in its own package under the GraphQL Tools project.
Okay. So each tool lives in a GraphQL package under the GraphQL tools. This pattern is also
To start,
similar
we're going
as the used, for example, in the React ecosystem and Vue ecosystem.
to install a tool for our schemas. Using npm, we'll install at GraphQL tools /schema. When you're doing this, make sure to install the scoped GraphQL tools package with this @ symbol, and not just GraphQL tools, which is no longer in development and has been deprecated. The GraphQL tools project is now split up into separate packages.
So we can do is look at the get started here. In GraphQL tools is a set of npm package here and an opinionated structure for how to build a GraphQL schema and resolvers in JavaScript, following the GraphQL first development workflow. So using GraphQL with HTTP, the GraphQL first philosophy, okay, separate business logic from schema, use standard libraries for auth and other special concern. But we're going to follow is what Adam actually no. Okay.
We can now
So let's going to use it's going to stop our server and npm install. You can use I for a shorthand. Npm install at graph tools graph hyphen tools schema. Okay. Alright. And beware with this because you might install is a if you don't describe that right, you might install some potential uh, you might install some potential powerful script. So npm install here and it say, hey, graph tools, perhaps it didn't write GraphQL tools, luckily for us, it's not an npm register because it's GraphQL tools. So right now I'm using npm. You can also use yarn or something called pnpm, performance npm, pnpm, yes, and that's right.
import this module
So
near
we
the top of our
importing this
file,
model,
specifically taking a
and let's go to write what we have done so far here. So I install is this. So here I'm installing is a GraphQL
function called make executable schema by destructuring the result of our required GraphQL tools package. This replaces our build schema function with make executable schema. This takes in an object, including this typedefs property, which contains an array of schema strings. So we'll replace our build schema with a schema created by calling make executable schema, passing in typedefs, followed by an array containing our schema strings, where typedefs is just how GraphQL tools.
Again, this is very narrow specific to this technology. Okay, and it is important. So using a so using make executable schema using make executable schema from the GraphQL tools package schema where we can pass an array of types files in our type system like this. And they use this like this. So okay. Oops. Hey, hello. What up? And move on.
calls schemas. So we could pass in our one schema to rule them all here. Let's move this into another variable above our make executable schema called schema text, which we'll pass in as the single value of our array, schema text. We can now remove our build schema call and remove the import at the top of our file. We're no longer going to be using this build schema function. The schema returned by make executable schema is fully compatible with the GraphQL JS package, which means that we don't have to change anything when we pass it in to our Express server. But right now, we're just doing what we were doing before with a fancy new function. The benefit of this approach is that we can now split up our schemas so that we no longer keep it all in one long string, and instead, we can organize things into folders that correspond to our features. For example, products and orders. Now, one pattern that you might see on larger projects is these .graphql files. For example, products.graphql, and for orders, orders.graphql. We can now put all of our GraphQL type definitions or schemas into these files.
So something you will see in large project something you will see in large project is define a GraphQL schema file, right? GraphQL or a GraphQL schema file.
For example, we have the product type and the related review types, which would both go into products.graphql, and the order type.
So since they're using schema text, okay, since we're using this schema text,
and each order
for server, something that you're going to see in larger project is schemas organized by features in order. In total, that's right. So products and orders. So something you're going to see a lot of is in a new file here. the product dot GraphQL. Yep, the product GraphQL. The products GraphQL and the orders GraphQL. So since we're here using is the executable package, what we're using is following the structure syntax, where you have is when you import that model, logging is the required since we are on a common GS model resolution. GraphQL tool schema, I just want to explore is the make executable schema. So what we can do here is define another schema. You say context schema, okay, where you're going to call this schema, and since this is an object that you're going to pass here, where you have to define is a type def, you're going to pass is a collection of type definition here.
Type definitions or schemas into these files. For example, we have the product type and the related review types, which would both go into.
So what we did here in our schema text, or this schema text,
going to be using this build schema function. All here. Let's move this into another variable above our make executable schema called schema text.
Okay, so what we did is just to get this, but using as a backticks for that. Yep, using the backtick for that. Schema text. And here we use this type def. Right below we define is the schema text, where we paste is this. Okay, and
which will pass in as the single value of our array. Schema
is schema text. So this is just to make sure that this actually works as expected.
text. We can now remove our build schema call.
So by removing the schema call
and remove the import at the top of our file. We're no longer going to be using this build schema function. The schema returned by make executable schema is fully compatible with the GraphQL JS.
And here we define is the schema. So now it match our schema
package, which means that we don't have to change anything when we pass it in to our Express server. But right now, we're just doing what we were doing before with a fancy new function. The benefit of this approach is that we can now split up our schemas so that we no longer keep it all in one long string, and instead, we can organize things into folders that correspond to our features. For example, products and orders. Now, one pattern that you might see on larger projects is these .graphql files. For example, products.graphql, and for orders, orders.graphql. We can now put all of our GraphQL type definitions or schemas into these files. For example, we have the product type and the related review types, which would both go into products.graphql. And the order type and each order item would go in the orders file. Now, you might be asking, what about this query order type and the related review types, which would both go into products.graphql. And the order type
and the order type from here, and the ordering item here, will both go here on the order GraphQL file.
And each order item would go in the orders file. Now, you might be asking, what about this query type that contains both products and orders? The one that lists.
So, so by defining is this files in our case, okay, in our case is this GraphQL product product products.graphql. And for the orders, the orders order GraphQL. Order GraphQL.
All of the queries our API supports. We can define part of the query type in each of our GraphQL files. So we'll copy this definition and paste it here at the top of our products file, but only include the products list. And in orders, we'll include only the orders list, just like that.
So, and again, this is a one way to include is the root point or this entry point, where in this case is the type of query, which you're gonna add this as product, and in orders, you define is what? You define is the orders. And what will happen is that it will merge behind the scenes. So what's going to say is in our folder here, in order, we're going to define is this type query order and type query products, which will be the entry point of our GraphQL, and we'll pass the definition or import.
Now, if we pass these files into our make executable schema function, it will combine our type objects by merging them, and we'll get a single query type with both the products as well as the orders. By the way, if you want this nice syntax highlighting and you're using Visual Studio Code, we can go into our Visual Studio extensions and install this GraphQL extension for Visual Studio Code. That includes things like syntax highlighting and validation of your schemas. This might help you catch any typos in your schema file, and is overall just a nicer development experience. Now, how do we load in these schema files and pass them into our make executable schema function as an array? Remember, each of these items in our array is a schema string, just like with our build schema function. We could load each of these GraphQL files individually, but there's a GraphQL tool to help us with exactly this problem. First, let's get rid of our old schema text, which we don't need, and we're going to
get rid of all of our schema type. There must be a loader function.
npm install, again from the @GraphQL tools.
Okay. Is here. However, how do we import all of our files in our schema? So there is this tool.
Scope, the GraphQL tools project, this time the /load files tool.
So GraphQL tools, GraphQL tools load files, GraphQL tools tools load dash load files.
We can now import this module right above where we import our schema tool. And we're going to take this load files sync function from that import.
And again, using this load file sync, which will run at the beginning of your file. So if you install this load file from the graph utility tools, and then you import is the function. For example, here is load file sync from the model called GraphQL load file, and here you have is the load files or load file sync.
Like that. This function will let us read in any files matching some pattern and pass the text contained in those files.
Okay, so this file or this function, will allow us to load files following a particular pattern, aka block. Oh, come on, aka block.
Into our type defs over here. We're going to load our files into this constant that we'll call types array, which will be the result of load file sync, which takes this pattern to use when loading files for our project. We want to load all of our .graphql files and put those in this types array. So the pattern we're going to use will be a string that looks something like this: *****.graphql. This will look,
especially is plural types array, because we're gonna fetch multiple type GraphQL definition by using load file sync, and you're gonna pass this a particular pattern where is identify any file
will be a string that looks something like this: *****.graphql.
Exactly. *****.graphql.
This will look into any directories or subdirectories in our project. That's what the double asterisk symbol here means. Matching any files that have 0 or more characters, that's the single asterisk, followed by .graphql in their file name. We want our load files function to look relative to server.js. So we're going to use the __ dir name value. That's our global built-in, set to the full path of the current file, that's server.js.
You don't want to do this if there is a law, perhaps at the beginning when your server start. Okay, anytime your server start up, you may want to load this file sync, because you want your entire type definition file work. Or there must be some, and again, this might be advanced topic, but there might be some cool features to add in the GraphQL capability as your server start up, or as your server spin up.
Dir name value.
But here, you need to pass is the private variable dir name
That's our global built-in, set to the full path of the current file, that's server.js. And we're going to join that with our glob pattern here using the path module. We've done this a lot. We create this path.
Okay, we have done this a lot. And then we're going to is using the
constant that's set to require the path module, and we call the path.join function, combining the dir name with our file pattern.
Exactly. So the thing is that we need to identify. So we need to tell the path what is going to look up for the files, which is something that we have done in the past, using is the built-in model called path from Node, which is path, that this will merge or join this path here. So this is a built-in variable that indicates what is the path where this file is being called, the server, and you're going to look up or passes the pattern here where you want to look up for that. So I want this to join all of this path and pass that to the load file sync.
Finally, we pass in our types array to be
to
merged
the type definition. So finally, we pass our type array to the type definition
together into the final schema, the one right here, that's passed into our GraphQL server. The great thing about combining our schemas in this way, before passing them into our GraphQL server, is that the order of the values in our types array doesn't matter. As long as each value is a valid schema definition, and there's no conflicts of names, things should work just great. We'll see more benefits of this approach as we add more functionality to
and using this function to load files, sync, and pass it to schema, or to make executable schema function. To make executable schema, holy crap. Make executable schema function to load the type array. This is a useful approach, since as long as they are valid schemas, okay. So this is a useful approach, since as long as they're valid schemas, yes. So this is a useful approach, since as long as they're a valid schema and there is no name conflict,
our server. Things should work just great. We'll see more benefits of this approach as we add more functionality to our server. But before we go, let's take advantage of our folder structure here just a little bit more. We can also split our default values in our root object into a products data file and an orders data file. Let's make a new file in our orders folder called orders.model.js and a products.model.js. These files will be placeholders for our data model. If you remember back to our model view controller pattern, our models interact with our server's data. This could be data that lives in an array in memory, or a database, or some other
Yeah, an array
API.
in memory.
Right now, for our example, I'll move this orders array and export that from our model by assigning it to module.exports. But we'll assign the array to module.exports directly, just like that. We'll do the same for our products model, passing in the products array and assigning that to our exports.
So this will be useful for placeholders of orders, dot models, dot JavaScript. Where in here you're gonna export this into model export. Okay, model export, and since this is the order, we're going to pass is the orders. But we're gonna is just to get is the orders array, just like that. And the similar is for the product dot models, which will act as a placeholder for our data, which it can host on our server or in a database for someone else. And again, following is the model export for that. Okay. And here we're going to get only the product for that. The products for that.
Like that, which means in server.js, we can assign products to the value from
So
requiring
we're going to import
our
that.
products model. That's in /products /products.model.
So we're gonna
Notice that we're using the value from our require function directly without assigning it to a constant at the top of our file, because we'll be changing this code
from the product product model, okay, and similar for the orders. But in this case is the orders. Just wants to the autocomplete functionality works for me.
and improving it even more very shortly. But for now, let's assign the orders array to our orders model. That's in our current project /orders/orders.model. We can now run our server and test everything is working. So I'll clear the console and npm start.
When we see npm start, our GraphQL server is working. Say localhost GraphQL, and there you got it. Because it's expecting a particularly ID, expected iterable, but it didn't find one. Query products. And in our case, it's like product description, like that. So product description. So when we ask for this, we're gonna get the expected iterable, but did not find one for file. Query.products. Type arrays. So you're gonna load all of this by order, query, orders, and products. Of course, because there is no data inside of that. There is no data really?
Then going to our browser and reloading our graphical interface to test some query that includes both
Okay. Yeah, because there is some redundancy. Data redundancy here. Mm, 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 mm. There is some data redundancy here. The data is in there, but we didn't pass that correctly. So now it should get is the product description. Mm, Product description. Do I need to define them as with the extension? No, I don't need to. So you're going to import is products, the product.model for the order around this as a root value. Mm. So if I read this, it tells me expect iterable but did not find one for the field query.products. So we're going to explore this. And once you load files sync, you reload this. Get the same product. Data products, no. So we query, we had products, and like that. Query type products, where inside of the product you get its description, which is in a string. And for some reason, it's like you're not loading is, perhaps it's this, path.join. You're not loading is the data
In our
as,
server,
even though that I'm following is,
array, and the great thing about combining our schemas in this way
path.join. It's your name and this GraphQL. It's already working. But when it comes to this, the products in order, mm, there's something wrong
before
here.
passing them into our GraphQL server, let's take advantage of our data file. Let's make a new file. This could be data that lives in products model, passing in the products array, and assigning that to our exports like that, which means in server.js,
Because
we can assign products to
oh
the
my
value
god,
from requiring
exports.
our products model.
Model.
That's in dot
Thanks,
slash
Randall.
products
Thanks, Randall.
slash products dot
Thanks,
model.
Randall.
Notice
Okay,
that
so now it will work. So you reload this, okay, and then you fetch the data and you get that data. Jesus. Okay, model.export. Okay. Great, cool. It's done.
we're
It is
using the
looking done.
value from our require function directly without assigning it to a constant at the top of our file. Because we'll be changing this code and improving it even more very shortly. But for now, then Going Server is now looking much more organized. Let's keep it going in the next video. I'll see you there.
We should now replace this with extension GraphQL loading file. Other possible extension include this. Let's make data to make it easy to use with different file extension of your GraphQL But again, this is the way of how you can do this. Okay, meaning is that git status, say git add all of that. Okay, git status, git commit minus n, where you define here is a modular GraphQL server, or modular add modular GraphQL server using GraphQL tool package. Modular GraphQL server using GraphQL tool package. Like this. And you say, oh, alright, oh, git push origin to the main branch, and there you got it. Way much more enlightened. So what you can do is something that I'm going to mention that, but that'll be all for this section. Thanks for joining me, and I wish you the best. Bye bye. See ya.